Namaskar everyone, I am Narasimha Parity, engineering at Amrita University, Kerala. In this video, I am going to present basic computer instructions. First, let us go into the instruction code and its format. Instruction codes are basically the group of bits that tell the computer to perform specific operations. A processor which collects the information and decodes these bits to execute the instruction. And each set of a computer can have their own instruction set. An operation code can be consisted of an operation containing addition, subtraction, multiplication. And in order to perform these operations, we just need to follow a specific format for instruction codes. And it is divided into two parts. One is opcode, which is operation code, and other is the address of the data. Address of the data basically tells us the address of the operand on which the operation is specified by the opcode is performed. This is the general instruction format for memory reference instruction, which we are going to discuss about it later. Now we need to know that an instruction register contains an address and an OP code. Based upon the format for the instruction and codes, each computer has three instruction formats. The three 16-bit instruction registers are memory reference instructions, register reference instructions, input-output instructions. Now let us begin with memory reference instruction. These instructions refer to memory address as an operand. The other operand is always accumulator, which specifies 12-bit address, 3-bit opcode, but other than 111, and one addressing mode for direct and indirect addressing. Now let us look into the format. In the 16-bit instruction register, the first 12 bits specify as the address, the next 3 bits specify as the opcode, and the last bit indicates as the address mode, which is denoted by capital I. Generally, the operands can be specified in two ways: direct address and indirect address. And in this format, when I is equal to 0, which is indicating direct address, when I is equal to 1, indicating indirect address. Coming to the hexadecimal code for memory instruction register, the address field is denoted by 3 x's in hexadecimal rotation and is equivalent to 12-bit address. The last bit of the instruction represents by symbol I. When I is equal to 0, the last 4 bits of an instruction have a hexadecimal digit which is equivalent from 0 to 6, since the last bit is 0. When I equal to 1, the last 4 bits of an instruction have a hexadecimal digit equivalent from 8 to E, since the last bit is 1. A register reference instruction specifies an operation of the AC register. Operand from the memory is not really required. Therefore, the other 12 bits are used to specify the operation to be executed. Coming to the format, the first 12 bits are the register operation. Since it's a register reference instruction, an operand from the memory is not required. The 12 bits do not specify an address, but the register operation is to be performed. The opcode part is detected as triple ones, and the last left whole bit is 0. So whenever we encounter 3 bits as triple ones, we just have to look at the leftmost bit, because if it is 0, then it is the regular reference instruction. Coming to the hexadecimal code in this format, the leftmost 4 bits are always equal to 0111, which is equal to hexadecimal 7. So they all begin with hexadecimal 7. An input-output instruction does not need a reference to memory with opcode 111 and 1 in the leftmost bit of the instruction. The remaining 12 bits specify the type of input-output operation performed. Coming to the instruction format, the first 12 bits specify the input-output operation. The next 3 bits specify the opcode, which is equal to 111. But the only difference between register reference and input-output reference instruction is the last mode bit of instruction. And the last mode bit of instruction for input-output reference instruction is 1. Coming to the hexadecimal code in this format, the leftmost 4 bits are always 1111, which is equal to hexadecimal F. So they all are going to begin with hexadecimal F. Thank you.